Okay, hi and Assalamualaikum everyone. My name is Dila Hakim bin Hazulillah. I'm from BEY section 1/2. So, for today, I will give explanation of RC capacitor theory. Are you guys ready to hear my explanation? If you guys ready, let's go. Okay, so what is RC capacitor theory? Okay, so RC capacitor theory, I will give one example circuit. Okay, let's see this example circuit. Okay, this is the example circuit. If you can see, which is we have switch, we have battery, we have ground, and also we have resistor, and also capacitor. Okay, so for the explanation, here's the explanation. Okay, if a resistor is connected in a series with the capacitor forming an RC circuit, the capacitor will charge up gradually through the resistor until the voltage across it reaches that of the supply voltage. Thus, the transient response of a series RC circuit is equivalent to 5-time constant. Okay, so what we can conclude from this theory is, when the capacitor charges the upgradually through the resistor until the voltage across it reach of the supply voltage, the transient response of RC circuit will equivalent until 5-time constant. That's the explanation about RC capacitor theory. Okay, that's why they call RC capacitor theory from the explanation. Okay, so there is some of common question in the circuit. Always asking about the question in RC circuit. First, when a capacitor is fully charged in an RC circuit, okay? When a capacitor is fully charged in an RC circuit is when the current of the capacitor stops flowing and the voltage drop across the resistor is 0, and the voltage drop across the capacitor is equal to the supply voltage. Okay, which means that the situation when battery is removed and the resistor is connected in parallel with the capacitor. Okay, that's the common question of RC circuit capacitor question. Okay, so let's go. Okay, so I think that's all from me, from my explanation. I hope what I give the information about RC theory will give you some tips and gain some knowledge. Okay, next we will go to Anutik to explain about more on our project. Thank you.
Hi everyone, my name is Anutik Alakinikov. My job here are to present about circuit design by using RC circuit application. First, how RC circuit work on LED. As we know, a capacitor is a passive element designed to store energy in electric fields. Second, the capacitor acts as a temporary power source for the circuit. Next, its type is a voltage much bigger than a battery, thus so the LED. This is my circuit design by using multi-sim software. In this circuit, I am using the RC circuit application because when a circuit contains a single capacitor and several resistors and dependent source, the Thevenin equivalent can be found at the terminal of the capacitor to form a simple RC circuit. Also, one can use capacitor can be combined to form a single equivalent capacitor. Last thing, the capacitor also a cheap thing can buy in the market. This is for the circuit construction layout of this experiment. For the result and the percentage error, as you can see here, the percentage error between simulation and experiment are at the highest value. This slide I show us the difference between of two types in the first order circuit and the result of this circuit designing. The summary of this presentation are important characteristics of the basic element in first order circuit by using this table equation. That's all for me. The next presenter will show us about the circuit construction by following the circuit design. Thank you.
Assalamualaikum. Now I'm going to show how to construct our circuit simulation. I have already prepared the component. So what we need is one battery cell with 9 volt, ground, and 4 resistor with 3 resistor with 220 ohms, one resistor with 3k ohms, okay, capacitor with 220 microfarad, SPST switch, and two LED. So what we're going to do is to connect all the component to a circuit. Okay, so this is the complete circuit, and now we're going to run the circuit. Okay, when the circuit is an open circuit, the current cannot flow, which make the LED go light. But when I turn the switch to the closed circuit, LED will be light. Okay, as the LED is light, the current is flow through the component, which is resistor and capacitor. Okay, so resistor function here is used to restrict the flow electric current. If the resistor doesn't put in this circuit, the current flow can damage the LED. And here we got capacitor here as a storage for electrical charge. Okay. Now the capacitor here is initially uncharged as soon as the switch is closed. The current flow to and from the initial uncharged capacitor, okay, as charge increase on the capacitor plates, there is increasing opposition of the flow of charge by the repulsive of light charge on each plate. Okay. Okay, when the circuit is in charging state, the current will be in the forward from source positive terminal, flow through resistor, and going to capacitor positive terminal, which is like this. Okay, it's going from source, current will flow from source to capacitor. Okay, when the discharging state, the current will flow like this. From the capacitor, the current will discharge through resistor to the source.
Hello and Assalamualaikum. My name is Nasha binti Saiful Bahari. I'm from 1B1-2. So in this video, I will construct a RC circuit like the picture below for our group assignment. So for this project, we need a capacitor, 2 LEDs, one 3 kilo ohm resistor, 3 220 ohm resistor, some jumper wires, breadboard, and switch. Next, I will place the 220 ohm resistors. And then I place the jumper wire. Then I place the LEDs. Make sure the LEDs are placed correctly because it has anode and cathode terminal. And then I place another jumper wire. Next, I will place capacitor. Make sure it was placed correctly according to its positive and negative terminal. And then, I place another jumper wires. Then, I will place the 3 kilo ohm resistor and the other 220 ohm resistor. Last but not least, I place all the other jumper wires. And then our circuit is done.
Assalamualaikum and hi, my name is Nur Anida Farahin binti Abdul Rahman, matric number B0820103339. I'm going to talk about functionality of RC circuit. Before that, I'm going to explain about the function of each component that we use in producing this project.
Okay, the first component that we use is a battery. A battery is a device that stores chemical energy and convert it into electrical energy. In this project, we use battery 9 volt. The second one is a resistor. Resistor is a passive electrical component with the primary function to limit the flow of electric current. In this project, we use 4 resistors, which is 220 ohm and 3 kilo ohm. Next, we use capacitor. Capacitor is an electronic component that stores and releases electricity in a circuit. In this project, we use polarized capacitor. Polarized capacitor is a design for higher capacitance value. We use 220 microfarad. Next, we use light emitting diode, LED. LED is to indicate the presence of voltage or to produce the light. We use 2 LED in this project, which is LED red and LED yellow. Jumper wire. Jumper wire simply wires that have connector pins at each end, allowing them to be used to connect to points of each other without soldering. Jumper wire also used with breadboards and other prototyping tools in order to make it easy to charge a circuit as needed. And the last component that we use is switch. Switch is an electrical component that can disconnect or connect the conducting path in an electrical circuit.
This is RC circuit. Now I will show you the functionality of this circuit. When I turn on the switch, this circuit is in charging. The 2 LED will light up and the brightness is the same because they are in parallel. While capacitor is a device that stores electric charge. The capacitor is also in charging when the switch is on. Now I will turn off the switch. The brightness of LED will slowly decrease because the circuit are in discharging. The capacitor will also in discharging. I think that's all from me. Thank you.
Hi everyone, in this video I'm going to show you how to do the calculation for our project. So this is our circuit construction for our project. You can see here is the switch and then the resistor 220 ohm, 3000 ohm, and also capacitor is here and 2 LED. For these 2 LED, we are going to show the functionality, so we will not take account in the calculation part. When after closing the switch, capacitor acts as open circuit. So the capacitor is here, act like an open circuit. So everything is the same. And then you can see that 3K ohm resistor and 220 ohm resistor are in the parallel. So we can use the parallel resistor formula to find the resistor equivalence. So we can get 204.97 ohm. After this, we can draw another circuit like this, and the capacitor still is open circuit. So now we can start to find the initial voltage for the capacitor. We can find the initial voltage of capacitor by using the voltage divider law. So the capacitor voltage is here, so it's parallel with the 204.97 ohm. So we can use the formula voltage divider 204.97 divided by the total resistor 204.97 plus 220 times the total voltage, which is 9 watt. So we get the voltage of the capacitor is 4.34 wattage. After that, we can find the time constant, which is using the formula RC. So the equivalent resistor for the capacitor is 204.97 times 220 microfarad. So we get 0.045 seconds. So we can find the general equation for the capacitor. It's like this. So after that, we can also find the energy stored in the capacitor by using the formula half CV squared. So this is 0.5 times capacitor, which is 220 micro, and then the voltage is 4.34 squared. So we get 2.07 millijoule. After that, we can also find the current passing through each of the resistor. So like this one, we can find the total current passing through the first resistor with 220 ohm by using the Ohm's law. So we can find it here. V equal to IR, so we find the current is equal to R per V. So the total resistor here is 220 plus this one 204.97. So we can get the current total is 21.2 milliampere. After that, we can also find the voltage passing through the first resistor. Also by using the Ohm's law, then we get the value is 4.664 wattage, 4.664 watt. And then we can also apply the Kirchhoff current rules to find the current I1 and I2. For the current I1, we can use the current divider formula. which is this one. So we can get the I current passing through the 3000 ohms resistor is 1.45 milliampere, and the current passing through the second resistor I2 is 19.8 milliampere. That's all for my part. Thank you.